Hey everybody, in this video I'm going to talk about the process of inscribing a circle within a triangle and circumscribing a circle around a triangle. And this is all done on GeoGebra, so please follow along. I put the link in our course and you can do exactly what I am doing. Now actually when you first start in GeoGebra it looks probably like this, and you can click on more to open up more options. We'll do that in just a second. First, I'm going to set up a triangle. So I'm going to click on Polygon and then I will select the 3 points that I'm going to use. Any points will do, and then you need to click back on the first. Now, I'm going to write this down. We are going to start by inscribing a circle within, the triangle. So we want to have an inscribed circle. And the center of the inscribed circle is the in center of the triangle. And the in center, something we talked about a couple units ago, the in center of the triangle is always formed by the angle bisectors. So if I can bisect all of my angles and find where they intersect, that point is the in center. All right, so let's actually do that now. I'm going to clear all this off. So to do this, to bisect the angles, I'm going to need to click more. And this is a construction that we're doing, so it is within the construct category. So within construct, I'm going to click on angle bisector, and it says select 3 points or 2 lines. I find it easier to do the 3 points. It's just a little bit more specific. So I am going to start by bisecting angle A. So I'm going to click on C, then A, and once I click on B, now it has been bisected. Now I'm going to do this for the other angles. So angle B, I'll click on A first, then B, then C. Now I already do have the intersection here. Technically this intersection is the in-center, but I'm going to do it for all 3 angles. Do the bisector. So A, C, B. And you'll notice now we have this in-center where all 3 bisectors, angle bisectors meet. So I click on point. I go back up to the basic tools, click on point, and then I click on that in-center to actually plot a point there. That part's important. You need to define this point, this intersection. So this in-center is the center of the inscribed circle. To get the circle perfectly inscribed within this triangle, where it's touching each side only once within this triangle, I really need to find the perpendicular distance from the in-center to the side. The perpendicular distance, the straight distance from the in-center to the side, each side, is actually the same. So what I will do now is I will go to construct, and I'm going to construct a perpendicular line from one of my sides through point D. So perpendicular, select the line we want it to be perpendicular to, which is, I'm going to do this side AB. And notice now we have this perpendicular line, so I want it going through the in-center. And that line we just plotted, I'm going to do it again, is the one slightly to the right of the angle bisector. So you'll notice I start to have multiple lines here. So now that I found the in-center, I'm going to hide all the angle bisectors we did. So I'm going to go to Edit, Show, Hide Object, and I'm just going to hide the angle bisectors. So let's see, this line is an angle bisector. Oops, that's a point that I just clicked on. I didn't mean to do that. So this line, and then the angle bisector goes through C, so that would be this line. And now when I just go to maybe perhaps the move option, now all I see is the perpendicular line from point D to that side. So my last step now, this distance from the in-center to the side, that's the radius of our inscribed circle. So I'm going to use the basic tools, circle with center. Our center is the in-center. And then I will set the radius to be the intersection of, oh, and you know what? Let me back it up real quick, because I didn't give myself an intersection point here for my circle to kind of go through, and that can be very helpful. So I'm going to actually define a point real quick for where this perpendicular line meets the side. And now I can say with certainty this segment DE is our radius. That's a little bit better. So now I'll do circle with center, and I want my center point to be D and my radius to stretch to E. And you'll notice it now crosses the other two sides exactly once. And if we drew a perpendicular line from perhaps this side BC to D, that intersection point is also where the circle goes through. So this distance, DE, the perpendicular distance from the incenter to the side, is the radius of the inscribed circle. So this was an inscribed circle. Now let's talk about a circumscribed circle around a triangle where each vertice is on the edge of the circle. So I'm actually going to just delete everything we got. Delete, delete, delete. Boop, boop, boop. And I'm going to give myself a new triangle. So polygon A, let's see, I'll do it like this time. B, C. That almost looks like a right triangle. I did not plan for that. Okay, so the circumscribed circle, and let's talk about what this looks like and what it comes from. The circumscribed circle has the circumcenter as its center point. And the circumcenter, another point in your triangle, this circumcenter is formed by the perpendicular bisectors of each side. So wherever the perpendicular bisectors intersect, that point forms the circumcenter, which is the center of the circumscribed circle around your triangle. So let's look at this one. I honestly think this one's a little bit easier than the inscribed. So let's see, I'm gonna clear all this writing. And we have our triangle. Now I need to perpendicularly bisect each side. So within the construction category, perpendicular bisector is an option. And when you click on that, it says to select 2 points or 1 segment. So I think the segments would do just fine here. So first side I'm going to do is this longest side. So there's our bisector of AC. Next side BC. There's our bisector, perpendicular bisector. And then perpendicular bisector of AB would be right here. So I just clicked on the 3 sides, and now I have this one point, which let's define that point. So that is our circumcenter. Which means, and this is actually the cool part about this process, I have all I need. Because each vertice of the triangle should be on the circle. The distance from each vertice to this circumcenter is the radius. So now all I need to do is this circle with center, set it on the center point, the circumcenter, and stretch it to one of my vertices. And all the others will fall on the circle as well. And the other cool thing, I should have pointed this out with the in-center and the inscribed circle, but that's okay. When I move one of the vertices, everything follows it, right? So the circumcenter can be inside the triangle, it can be outside, it can even be directly on the triangle itself if you get the conditions to be just right. So please play around with this, and I hope you did follow along with me. Let me know what questions you have.